We're going to start talking about functions over the next few videos, so let's get right into it. So we're going to begin by defining a function, and this is page 21 from your handbook. And so we have that a function is just a set of ordered pairs, or a relation, in which each first component, which is called the input, there has to correspond exactly one second component, or an output. So when you put something into the function, one thing comes out. The set of first components is called the domain of the function, and the set of second components is called the range of the function. So let's fill in some blanks in this statement below. Given a relation in x and y, so notice this first sentence, or a few sentences, was kind of very general, and now we're specifically introducing x and y here. So given a relation in x and y, if to each value of x in the domain there corresponds exactly one value of y in the range, then y is said to be a function of x. Okay, so the domain, or the input, is x, and then the output or range is y, and then you would say y is a function of x. And then what we say about that is that x is the independent variable, and then y is the dependent variable. And then the set of all x values that can be used is the domain, and the set of all y values is the range. Okay, you can also back here say input in place of independent, and output in place of dependent. So here's another way to think about this. Another way to think about it, and I like to use this example because I think people can intuitively kind of see it, sort of think about like maybe a vending machine. Now this is not precise, but it helps you wrap your head around it. If you go to a vending machine, you would input money, and what would output was some kind of item. Let's go with snacks. So you input the money, but you type in a code, and then out comes a snack. Okay, so independently what goes in is x, is the input. You can put in any type of money you want that it'll take, like coins, dollar bills, maybe even swipe a card of some sort. That would be the independent variable, or the input. And then depending on that choice that you inputted and the code you type in for the snack you want, then a certain snack comes out. Okay, and that's the output. The range values are the output, the snacks. The input, the money in this case, would be the domain values. Now I want you to think about what would not be a function, because it might help you understand what is a function. Function is you put something in, something comes out. We're specifically thinking about math though when we talk about functions. So what wouldn't be a function is if you put something in and maybe nothing comes out, or more likely two things come out, or more than one thing comes out. So think of a vending machine again. If you put in money, you type in your code, and then two candy bars come out, but you only typed in the code for one, and you're supposed to get one item, then you might be happy, but that machine is actually not functioning correctly. So it wouldn't be a function. One thing goes in, one thing comes out, and that would be a function. So that's another way to think about it. Okay, so what I want you to do, and we'll pause in just a minute, is define a function in your own words. So in words that make sense to you. And then next, let's include an example and a non-example. So I'll show you one I'm going to pick, and you can pick any one you want. So y depends on x, so I'm going to say that if x is my input, I'm going to pick x squared. That's how I get y. So depending on my choice of x, I get y as my output. This is an example of a function. And here's why it's a function. Any one x number that I pick, when I plug it in, I will only get one y value. So for example, if I pick x to be 1, then when I plug it in, 1 squared is 1. It doesn't matter that it's the same number as x, that y is also the same number as x. That's irrelevant in this case. What we're interested in is if only one y value comes out of this function when one x value goes in. Same thing as if I were to pick -2. -2 squared gives us a 4. And so when I plug in a -2, I get out +4 for y. Here's a non-function. If I said something like y squared is x, this is not a function, and the reason being is if I plug in one number for x, actually more than one number for y will get me there. So let's pick x is 1 again. So if I plug in 1 for x, it says the following. I'll do it in a couple steps. It says that y squared is 1. And then I just think about, well, what number squared is 1? Or what's the square root? That's another way to say it. So if I square root both sides of this equation, whenever you take the square root, you actually have to put a plus and minus. So if I said square root of y squared equals square root of 1, I need to put a plus and minus on the side with my number. And so that says that y, because square root y squared is just y, the square root undoes the square. Well, the square root of 1 is just 1, but I have a plus and minus. So I actually have two values here. I have that y is 1, but y is also -1. And the other way to think about it is what number squared makes 1. So I'll show you a kind of a different way. -1 squared makes 1, but so does +1 squared. And so even though I plug in one x value, x was 1, I got out two different y values. Y was 1, but y was also -1. And so this would not be a function. It's like my vending machine idea. If I plug in one amount of money, type in a code for one snack, but I got two snacks out. So pause this and try to write the function in your own words and then come up with your own example and then something that you would say was not an example of a function. So let's continue on the next page, so page 22. We're going to now look at graphs and properties of functions. And so functions have a lot of characteristics. We are going to spend quite a bit of time graphing them, but this is just our first attempt at what's going on with the graph of a function, what kind of properties does it have. So we are given the graph of a function up here. I'm going to try to make it a little bit more clear, just coloring it in. And then we are graphing it on our xy coordinate system. So the vertical axis is the y-axis. The horizontal axis is our x-axis. Let me finish copying this. And this blue, it's not really curvy, but everything blue is our function. So we're naming it f. And so let's start with number 1. What is the value of f of 2? So notice how I said this out loud. F of 2. This is asking you the following. When x is 2, what is f of 2? What is y? So let me restate that. When x equals 2, what is y? What does y equal? So one of the big things with math is the notation. So this notation, f of 2, this is how you would translate it when you read it. So one of the things you're learning is how do I read math and translate it to a question or a statement that makes sense to me. And so real quick, why f of 2 means this is because our function that we named f is a function that can be written like this. Y equals f of x. So we input x into our function, we put input x numbers, and then the output is y numbers. And so if I have f of 2, that means I put a 2 in the function where x was. Now, I don't have a formula for this function, and we don't need it. We have its graph. So even though this function might be made up of some rule for x, we don't need that part because we have the graph. In the future, we'll start with the rule for the function, and then we'll graph it. But right now we're working with just the graph. All right, so let's answer this question. When x is 2, what is y? So x is 2, if I label my x-axis, right here. Okay, there's x is 2. And so the y value is this vertical value here. So if I go up from 2, there's my point when x is 2, what is y? Well, if I kind of go to the left here, let me label these tick marks so they're more clear. This is 4. So the corresponding y value, and I'll just fill that in, I'll dot that for us. When x is 2, y is 4. And we write it as an ordered pair, 2, 4. X is always first. In your ordered pair, x is always first, and then y is always second. So the answer to this question is 4, and you can say f of 2 is 4. All right, see if you can do number 2 before I do it. Okay, so this is saying, if you translate it, what is y when x is negative 6? So f of negative 6, if you go to your graph, x-axis down here, I labeled it right here, x is negative 6, and you have to go find your graph. It's actually down this time. So if I go down to the graph, the point on my graph, when x is negative 6, well, what's y? And I'll just go across to the y-axis. It's 1, 2, negative 2. So when x is negative 6, y is negative 2. So f of negative 6 is negative 2. Question 3. At what x values does f of x equal 3? So notice how the notation changed. The parentheses, which is holding our x value, no longer has the number inside of it. So this is actually saying, well, what's the x number that gives you a y value of 3? So you can translate this as when y equals 3, what is x? And so that's because back here, y is f of x. Your function, it depends on x, so you input x and then y comes out. So when you have f of x equals a number, the number it equals is the y value. So you go up on your y-axis when y is 3, which is right here, and it says what is x? Well, if I label this point, I already know the y value. The y value is 3, and if I go down to the x-axis, we are right above where we labeled x is 0. So x is 0 when y is 3. So x equals 0. Let's do number 4. At what x values does the function have its maximum value? Okay, so you know intuitively what maximum is, even if you don't know what it is mathematically. It's the same thing you already know. It's just highest or largest. So what is the biggest value on your graph, and what x value gives us that number? So if you look at this function, here's the highest point right there. Right here is the highest point. And so the question is, what x value does the function have at its maximum value? So the maximum value is right here. And whenever you're asked about maximum value, just really quick to mention this, it means the y value is the maximum because that's like the height here. So technically the maximum value is the 4 part of this point. And so it's saying what's the x value? And the x value right here is 2. So x equals 2. At what x value does the function have its minimum? Okay, I want you to pause this and you find the minimum. What's the x value when you have a minimum on your graph? Alright, did you find the minimum point on your graph? It's way down here. And the y value, the minimum y value is negative 2, but the x value that gets you that point is negative 6. Okay, part 6. Over what x values is the function increasing? And then express the answer in what's called interval notation. So increasing. Increasing means going up, and up toward the right specifically. And so if we look at this graph, notice where it's going up. The graph only goes from negative 6 until this looks like positive 6 over here. So from negative 6 to positive 6, when is the graph going up toward the right? It's going up toward the right from here to here. Okay. It's constant right here. It's not going up or down. It's going up again toward the right from here to here. Then it goes down to the right, and then it starts going up again in this last little piece. So let me label the x-axis right here at this point. This is -4 for the x-axis. This point happens at -2. This point we labeled. This point looks like 2, 3, 4. Okay, so I want to label those for a reason. Now let's see, I'm going to switch colors. Alright, so the graph is going up, increasing from here to here. So it's increasing in this section, going up. Notice where it's going up, starting at this point and stopping at this point. Now what I want you to be aware of when it asks you about this in interval notation, it's asking about the x numbers. So just a note for us, this is saying, tell me about the x values. So the graph goes up from this point when x is -6, and then comma, until this point when x is -4. So I want you to be really careful here. This is not going to be an ordered pair. It's not a point on the graph. This is x numbers. Okay, so this is the same as me saying x is between -6 and -4. And then what we're going to do is we're going to use parentheses because that's part of our interval notation. It's saying that you get the graph is going up anywhere bigger than -6 and anywhere less than -4 for the x-axis. Alright, then it's constant. It's not going up or down. It's not increasing right here. But then it starts going up again in this section. So it goes up or increases from when x is -2 until x is +2. So between these two x numbers, your graph is increasing. So from -2 for x until +2. So that what that says is when x is between -2 and +2, the graph is going up or increasing. And then we connect these intervals with this capital U looking symbol. It's called the union symbol. Okay, so the answer here that's being asked about is above my line that I'm drawing. What I put underneath the line is just a way for you to understand what this notation is saying. Then the graph goes down or decreases here, and then it increases again right here at the end. And let me label this last x value. X is 6. It's increasing from when x is 4, and then it keeps going up until x is 6. So it's increasing here. So we have from -4, or sorry, not negative, +4 until 6 with our parentheses. And this is saying when x is bigger than 4 and less than 6, the graph is going up or increasing. So let me clarify one more time. This is not points on the graph. This is more so like the number line. I'll make it even more clear. I'll show you one more way because I do see a lot of people get confused on this. So I want to make it really, really understandable for you. So this is another way to think about what I'm talking about. If you only focus your attention on the x-axis, if I look back at my graph, let me go up here with the graph. If I kind of copy my x-axis, I have -6, -5, -4. I'm only labeling the points that I kind of need to focus on. -2, let's put 0 there, 2, 4, and 6. Okay, so if I only focus on my x-axis, my function was increasing between these x values from -6 to -4. It started to increase again from -2 to 2, so in between these x values. And then it increased again in these x values. Alright, so that's what this answer is talking about. When you are talking about interval notation, this is what you're answering. You're using just the x-axis, and so you're saying from here till here. From this interval to there. This interval here. And so that's what this parentheses is about. And then the union symbol to connect these. Okay. Alright, let's see what this one says. Part 7. At what x values does the function equal 0? So if you look at your function now, when does its y value or output equal 0? It doesn't say y value, it doesn't say output, but the function, it equals the y value. So that's what it implies. What's the y value? When the y value is 0, what's x? So if you want to translate that, when y is 0, what is x? And if you look at your function, your y value is 0 here when you're touching the y-axis, because y is 1 going up, it's -1 if we go down, so y is 0 anywhere on the x-axis. So here and here. So that's when x is -5, and then it happens again when x is 4. There's 2 points on our graph when y is 0. Okay, part 8. Express each answer in interval notation. Over what x values is the function positive? And then over what x values is the function negative? Okay, so positive, the function, remember, is the y values. It's asking about the y values. So the function is positive anywhere above the x-axis. So anywhere above. It's negative anywhere below the x-axis. So I'm going to do the first part and you'll do the second part. So over what x values is the function positive? Well, notice we're in negative numbers here, and we start going positive after -5. So starting at -5, and then we're positive, 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 positive. It's 0 here, and unfortunately 0 is not positive or negative, so we have to mention this. And so we have to stop at 4. We have to say that the function is positive from -5 until 4. And then after 4, it's still positive, but we can't include 4. So it looks like this. From 4, it's positive again from 4 to 6 here. So here's why. At -5, it's not positive either. It's actually 0. And then, oh, let me change something really quick. This is going to be a bracket. Okay, here's what I'm trying to describe. At -5 and at 4, our function is 0, which is not necessarily positive. 0 is not positive. And so we have to use parentheses anytime we can't actually equal a value. We use parentheses to say, like, we include that number very close to that number, but we can't actually say it's equal at that number of value. But then notice at 6, where our graph ends, this is definitely positive. This is like +2 at 6. So a bracket signifies that that is true, that this is actually equal, this is a positive number. Okay. And then our union symbol to connect it. So between -5 and 4, our function is positive, but not necessarily at -5 and at 4. So we use parentheses. We have to exclude 4 and kind of jump over it, because 4, the function value is 0. And then from 4 until 6, our function's positive again. It's above the x-axis. And then at 6, when we stop our interval, because our graph ends, we can use a bracket because this is equaling a positive number. All right, so pause this and answer part B. When is this function negative over what interval of x values? All right, did you get from -6 to -5? That's the first thing. If you got those numbers, that's good. The other thing is the brackets and the parentheses. So the function has negative output values only right here. This is the only time the function's negative, between -6 and -5. Now you can include -6 for x because it equaled a negative y value, a negative function value. So that's why we put a bracket on the -6. But -5, when we plug that into the function, it equaled 0, which is not negative. So very close to -5, like if I plug in -5.1, we would have had a negative value down below the x-axis. So we just say we get close to -5, but exactly at -5, it's actually not a negative function value. Next, number 9, what is the domain of the function in interval notation? So remember what that meant from the previous page. Domain is just the inputs. So in this case, the x values. And so you just look at your entire graph, and you say, where does my graph go in terms of the x-axis? What does it cover? It goes anywhere from -6 all the way to 6. It's everything in between. There's no holes or gaps or anything. It starts at -6, stops at 6. So our interval notation for our domain starts at -6. There is a function value there, so we use a bracket, and it stops at 6. So we also use a bracket because there are points there. The function has solid points there. In the future, we'll see like open points, like open circles, and then we would use parentheses, but these are solid points. There's no holes in this graph. What is the range of f? So the range is the y values. So if you look at the y-axis, what does the y values cover? And so you have blue graph anywhere, so there's none down here, but starting at -2 and all the way up, there's blue graph until y is 4. After that, there's no more graph. So anywhere from -2 until 4, there's graph, there's blue function. So from -2 until 4, and there's points all in between there, so we use brackets. The last part on this one, number 11 here, using the graph, express an interval notation where the slope of each line segment is the following: positive, negative, 0, or undefined. So let me remind you really quick. Slope is like the steepness of a line. It's rise over run, if you've heard that before. So let me go back up here actually. So when is the slope of the graph positive? Well, we kind of already addressed this question. This is very much similar to number 6 back here. So positive here, the slope is positive because it's going up to the right. It's positive here, and it's positive here. Where is the graph going? Up to the right, increasing. The only difference in our answer for number 11 here with the positive bullet point is that we are going to actually use brackets and not parentheses like we did in number 6. So our graph has a positive slope between -6 and -4, and then again from -2 until 2, and then again from, actually I could just use commas on this one. Union notation is okay, but we are sort of just listing here when is it positive. So commas would have also worked on this one. And then last from 4 to 6. Okay, so real quick, why I'm using the brackets this time and not the parentheses like I did when the function was increasing is because the slope is positive exactly at these points as well. At this point, -6, -2. Whatever the slope is of my function at that point, it is positive at that point. It's positive all the way up here. To include this point, it's positive right there. So we use the brackets. When is the slope negative? So this one, let's look at our graph. Our slope goes up, our function goes up, it stays the same, it goes up, it goes down to the right. Okay, down to the right means decreasing, which also means a negative slope. So let me put that with the other color. The function is decreasing or has a negative slope if it goes down to the right. So between 2 and 4, between 2 and 4, the slope is going down. It's decreasing, it's negative. And so that's a negative slope between 2 and 4, okay, on our x values. When is the slope 0? So remember, slope is the steepness of our curve or our line here, our function, and you can think of it as rising over running. It's like steps, up and over, up and over. Well, when is the slope 0? When are you not rising, but you're still running? Because 0 is the same thing as 0 over a number. So 0 is not 0 over 0. That'd actually be undefined. 0 is like 0 over 1, or 0 over 2, or 0 over 3. And so hopefully you can kind of see it from over here. The slope is 0 right in this area because we're not going up, we're not going down, but right here we're just running. We're just running straight. So the slope didn't go up or down, the function didn't increase or decrease. So between -4 and -2, these two x values, we're just staying the same, we're staying constant. And so that's when the slope is 0, between -4 and -2. And then last, when is the slope undefined? Well, undefined would look like we are dividing by 0. So anytime something's undefined, let me just kind of separate this. Okay, we're dividing by 0. So it could be any number on top, but if we're dividing by 0, it's called undefined. It's considered undefined. So that would be if I'm rising some amount, but not running. So if there's anywhere on the graph where we only rise, but we don't run left or right, then it would be an undefined slope. And that would be a vertical line. There's no vertical lines here, so this one we're going to say nowhere. You can say something like this circle with a slash. It's called the empty set. Or you can just say nowhere, or it doesn't apply, or something like that. Okay, so this is our introduction to functions.